Hello everyone and welcome to my class. Today I will discuss some questions based on powers and exponents. This will be helpful for class 7 and class 8 students. So let's start. So here is our practice sheet. Here are basic questions given to you. Now let's see how we can solve this. Before solving this, I hope you are clear with the rules of the exponents. You are clear with, very familiar with the terms, what is base and what is exponent. So let's try solving it together. The question is, write the base and exponent of each of the following. So as you know already that if we represent any large number, the multiplication of the number to itself several times, we can use this exponential notation. So here the numbers are given in exponential notation and we have to represent, we have to identify the base and the exponent in this exponential notation. So see, the number here which is written in the bracket, that is minus 5, it is raised to the power 4. This means that we have to multiply minus 5 to minus 5 itself 4 times. So this is indicating this. So for this, the base is minus 5 and the power, or I can say the exponent, it is 4. Always remember that the base should be written in the comparatively bigger size as compared to the power, and power is written in the smaller size as compared to the base on the top right corner of the base. Okay, so this is the exponential notation, the way of writing repeatedly multiplication of a number to itself, and it is very useful expressing the large numbers. So this is how we have identified the base and power of A. Similarly, you can also solve the other questions. Here the base would be 7 and power, or I can say the exponent, is 3. Okay, so like this you can try also. Now let's try the C1. Yes, you are right. Here the base is minus 2 by 3 and the power here is 5. This means that we have to multiply minus 2 upon 3 to itself 5 times. Okay. So this is all about the first question. Now let's come to the next question, that is the exponential form. Here the numbers are written in the expanded form and we have to write this in the exponential form. So for this, the first one, which number is multiplying to itself? Yes, you are right. Minus 4 is multiplying to itself. And how many times? Yes, it is multiplying to itself 3 times. So here very easy, the base is minus 4 and power is 3 because it is multiplying 3 times to itself. So when you are going to represent it in the exponential form, it can be written like this, minus 4 to the power 3. Similarly, if you see to B question, B is 25 upon 81 and you know that the factors of 25 are 5 multiplied by 5. and the factors of 81 are, no, 81 is 9 multiplied by 9. So here this is 5 to raised to the power 2 and here 9 raised to the power 2. So that means this 25 upon 81 could be represented in the form 5 upon 9 raised to the power 2. Okay. So like this you can also try number C and number D. Okay. Yes, the answer of C is 4 upon 9 raised to the power 2 and the answer here is 11 upon 12 raised to the power 4. I hope this is clear to you. Now moving to the third question. Yes, here we have to simplify and express the following in exponential forms. See, all the operations involved in all the parts is multiplication. So we have to apply a rule here, rule of exponents. Can you tell me which rule? Yes, absolutely correct. We have to apply this rule where the base is same and powers are different and the operation is to multiply. So for this rule we have to apply. We have to add the powers. So applying this rule, this question will be solved very easily like this. Like this is 2 to the power 3 multiplied by 2 to the power 5. So this could be represented as base are same. So base is 2, same base, and the powers need to be added. So like this it is equals to 2 to the power 8 and we have to represent each in exponential form only. Again solving B1, this is 4 to the power 5 multiplied by 4 to the power 3. So this will be, the base is same and powers are different, operation is multiplication, so you need to add the powers. So like simply the answer is 4 to the power 8. Got it? Further you can solve it as 4 is represented 2 to the power 2. So further if you want to solve it further, it could be represented like this. And finally in simplification form it is written as 2 to the power 16. Why 2 to the power 16? Yes, because here we have applied another rule which is a to the power m whole to the power n. Okay, so here we have to multiply the powers. Sorry, it's n. Okay, so these two rules we have applied here in this question. Now similarly you can solve the next question. Here the base is involving a negative sign, so let me solve this. Minus 1 upon 5 to the power 2 multiplied by minus 1 upon 5 to the power 7. So this is minus 1 upon 5 to the power 2 multiplied by minus 1 upon 5 to the power 7. Again the base is same, so we have to write minus 1 upon 5 as it is and add the powers. So it will be equal to minus 1 upon 5 raised to the power 9. So this is the final answer. I hope this rule of multiplication of two exponents with same base but different powers is clear to you. Now over to the next question based on the next rule. Yes, here it is. Simplify the following. Now here the base is same, powers are different, and operation is to divide. So for this we have to use another rule, that is a to the power m divided by a to the power n, and this is going to be a to the power m minus n. Remember here m is greater than n. Got it? So let's solve it. Let's see how to apply this rule to the given question. So here it is, 3 to the power 8 divided by 3 to the power 4 will be equal to 3 to the power 8 minus 4, and it is equals to 3 to the power 4. Okay. Similarly, now I am taking this example with negative base. You can try this b and d part on your own. So minus 6 upon 7 raised to the power 9 divided by minus 6 upon 7 to the power 4. So this will be, the base is same, that is minus 6 upon 7, the base is same, and the powers need to be subtracted from each other as the operation is division. So this is minus 6 upon 7 raised to the power 5. I hope this rule is also clear to you. A to the power m divided by a to the power n is equal to a to the power m minus n, where m and n are integers. Also a is any rational number, right? So rest two questions you have to apply, you have to try it on your own. Now here is the next question, simplify the following and write in exponential form. Yeah, looking at this, we have to use another exponential rules which we have learned. So the first rule is a to the power 0, and yes, the value of this kind of exponential number is always equal to 1. Any number raised to the power 0 is equals to 1. So this is one rule, and the next rule which we have already discussed in one of the above questions, that is a to the power m whole to the power n. In this case, this will be equal to a to the power the product of m and n. So we have to apply these rules here. So let's see, let us do it together. Here 9 raised to the power 2 bracket raised to the power 7. So here applying this second rule, it is equals to 9 to the power 2 multiplied by 7. So the answer is 9 to the power 14. Now the next one, the B one. It is 6 upon 11 raised to the power 0, now raised to the power 5. Now you know, first of all we have to solve this small bracket. So 6 upon 11 raised to the power 0, the value of this is equals to 1, and 1 raised to the power 5, that means you need to multiply 1 to 1 by 1 5 times. So the answer is 1 only. So this way you can solve these type of questions. Remember, this is very easy. Once you memorize these rules, these formulas, and practice it, and one tip for you all, that whenever you have to solve such kind of questions, always make it a habit of writing these rules in top right side corner until you are handy at it. Okay, so it will help you a lot. Now the next question, sixth one. It is simplify the following and write in exponential form. So let's do it. You know that here the base are different but powers are same. So we have to apply here one another rule. So which is equals to a to the power m multiplied by b to the power m. So this rule says that when the base are different but powers are same, we have to use this rule. You have to multiply whatever operation is there. If it is multiplication, then you have to do the product of the bases, but if there will be the division, then you have to divide the bases and apply the common power. So here we are going to apply this rule. So let's see. Yes, so this is a1, 5 raised to the power 3 multiplied by 10 raised to the power 3. So this is going to be 5 multiplied by 10 whole to the power 3, which is equals to 50 raised to the power 3. And remember, we have to write it in exponential form. So we are not going to solve it further. We will leave it here only. Now next one, similarly, now I hope B you will try it on your own. Now let us see the C part. This is a to the power x multiplied by b to the power x multiplied by c to the power x. See, here also we are going to use this same rule. No matter whether the number of terms is increased here, the rule, the concept will be same. Here which rule which we can apply in the case of 2 terms, the same rule can be applied in case of 3, 4 or any number of terms. But remember the thing that the bases are different, operation is same, multiplication and the powers is same. So this is going to be a multiplied by b multiplied by c raised to the power common power, that is x. So it is equals to abc, the term become abc raised to the power x. So I hope this question is clear to you guys. I want these b part and d part, you can solve it on your own. Now moving to the next question. Again there is simplification. So let's try it. a1, b to the power 4 multiplied by b to the power 5. Yes, the bases are same, powers are different and the operation is multiplication. So yes, right, we have to use the first rule which we have applied. So it is equal to b to the power 4 plus 5, it is raised to the power 3. So this is going to be b to the power 9 raised to the power 3 and it is equals to b to the power, it's 27. Okay, can you tell me which rules we have applied here? Yes, we have applied these rules. Remember, you have to mention each and every time whenever you are using the rules, make it a habit of writing these rules here. It will help you to remember the rules. Okay, here we have applied these rules. Now the next one, b1, this is 8 multiplied by x to the power 4. So this is b, this is 8 multiplied by x to the power 4 multiplied by y to the power 5 divided by 4 multiplied by x to the power 2 multiplied by y to the power 3. So let's see how we can solve it. We have to apply the rule of exponents here. So first of all, it can be cancelled out. So this will be cancelled out, leaving here 2, leaving here 1, and this x square and this x to the power 4 will be cancelled out, as this is x repeated multiplication of x 4 times and this is repeated multiplication of x 2 times. So this will be cut, and here the power will become 2. Again here this will be cut from down, and here the power will become 3 powers cancelled, and here the power will become 2. So whatever left is 2 multiplied by x square multiplied by y square. So 2, the bases are different but the power is same and operation is multiplication. So you can write it like this, xy square. Okay, so we can write it like this, 2 xy square. Or further, if you want to write them separate, you can write it like this also. So this is the classification. Now C1. C is 7 to the power 0 plus 3 to the power 0 raised to the power 2. So this is inside the bracket, you have to solve. 7 to the power 0 is 1, 3 to the power 0 is also 1. So this will be like this, and 1 plus 1 is 2, so 2 raised to the power 2. This is the final answer. Now the D1, it's 9 to the power 0 multiplied by 4 to the power 0 to the power 3. So this is 9 to the power 0 is 1, 4 to the power 0 is 1, whole to the power 3. So that is 1 to the power 3. Okay, that means 1 only. And this is 2 to the power 2 is 4. So like this you have to solve. So see the beauty of powers and exponents, the beauty of these rules. Once you remember this and once you practice it, you learn the art of applying these rules, the questions become very easy. So here is another question. Here we have to find the value of x in each of the following. So let's try to solve it. So first one is 2 to the power x and 32. Yes, here we have to find the prime factors of 32, and let's find it out, the prime factors. So we will divide it by 2, as the unit place is 2, so it is easily divisible by the first prime factor, prime number, that is 2, smallest prime number. So it will go 16 times. Again it is divisible by 2, so 2, then 8, then 2, then 4, then 2, then 2, then again by 2, and so on. So you know that here the prime factors of 32 is 2 repeatedly multiplied by 2 itself 5 times. So this is like this. So this will be equal to 2 to the power x is equals to 2 raised to the power 5. So on comparing, you will find that the value of x is equal to 5. Similarly, you can solve the another question. For this, you have to write down the prime factors of 31. So the B1 is 3 raised to the power x plus 1, and it is equals to 81. Okay, so 3 raised to the power x plus 1, and you know the prime factors of 81 are 3 multiplied to 3 4 times. Okay, so this is 3 raised to the power x plus 1, and this is 3 raised to the power 4 on the right hand side. So on comparing, you will find that x plus 1 is equals to 4. So this implies that the value of x is 3. Okay. So I hope this question is also clear. Keep practicing such type of questions so that it will be fun for you. Solving these questions will be fun. Okay. Now this one. Yeah, here also we have to apply the rule of negative exponents. You know it very well. If this is the minus 5 upon 3 raised to the power 2, if you do its reciprocal, then 1 upon a particular number x is it can be represented as the reciprocal. You know, you have learned this concept in your earlier classes. So this is going to be minus 3 upon 5, or you can say 3 upon minus 5 rather. So this will be equal to 3 upon minus 5 raised to the power 2. Okay. So this is 3 square is 9 and minus 5 square is 25. So this will be 3 multiplied by 3 and here minus 5 multiplied by minus 5. Okay. So here you have to solve it like this. The B part is very easy. 4 upon 5 to the power 1 whole raised to the power 2. So we have to apply the rule, which is a to the power m whole to the power n. So we have to multiply the powers 1 by 2. So that is 4 upon 5 raised to the power 2, which is equals to 4 multiplied by 4 upon 5 multiplied by 5. So the answer is 16 upon 25. Okay. Now the last question, question number 10. Here also you have to evaluate the following. Very easy. You know it that 8 raised to the power 0 is 1. So here 4 to the power 0 plus 3 to the power 0 whole raised to the power 0 is going to be 1 plus 1 whole to the power 0. That is 1 plus 1 is 2 and 2 raised to the power 0. The final answer is 1 only. Here we have applied this rule. A to the power 0 is equals to 1. This rule we have applied. Now the next one. 6 upon 5 plus 2 upon 5 raised to the power 2. This is going to be 6. That means 2 multiplied by 3 and here it is 5. And here this square, so that is 2 multiplied by 2 and 5 multiplied by 5. So this is going to be, we can take common. Okay, common from these two fractions. So let's see what common things we can do. This is 2 upon 5 common and this is 2 upon 5 common. So this 2 upon 5, let me write it here. So this is 2 upon 5 common thing. Here it is multiplied by 3 and here it is again multiplied by 2 upon 5. So here involving the addition of fraction and a whole number. So this here we can do the cross multiplication. 5 3s are 15. 15 plus 2 is 17. So this is 17 upon 5. Okay. Here we have done the cross multiplication. 3 5s are 15 plus 2, that is 17 upon 5. Now multiplication of fractions, you know it very well. You have to simply multiply the numerator of one fraction with the second fraction, numerator of the second fraction, and to multiply the denominator of the first fraction with the denominator of the second fraction. So this is going to be 17 2s are 34 and this is 5 5s are 25. So this is the final value of this particular question. I hope this practice sheet, there is no problem solving this practice sheet. So again, I am happy to see that you are getting your speed in solving